Hi friends, let us see what is a function. Let A and B be two sets. Let A and B sets. Suppose there exists a correspondence exists a correspondence that is denoted by some years by year which associates to each member in A to a unique member in B. Then F is called function or a mapping from B to if A and B be any two sets, and if suppose there exists a correspondence that is denoted by year, which associates to each member in A to a unique member in B, then F is called a function or a mapping from set A to set B. That is, each element in A have a unique image in a set B. So, let us see what is a domain and codomain and range of a function. First, F here is F is a function from, and if F is a function from A to B is denoted by and is denoted by, if F is function from A to B, then it is denoted by F is a function from set A to set B. So, if F is a function from A to B, then set A is called set A is called domain of F, and set B is called codomain of a function F. Is the domain and codomain of a function F is nothing but, if F is function from set A to set B, then set A is called the domain of a function and B is called the codomain of a function. Here, each element in A has a unique image in B. In function from A to B, each element in A has a unique image in B. But it is not necessary that each element in B has a pre-image. That is, for every element in B, there exists an element X belongs to A such that the image of that element is in B. That is, that particular element is an element of a set A. So from this, but each element in B has no pre-image. No pre-image. It means that there are some elements. There are some elements in B. Elements in B which have no pre-image. Which have no pre-image. Okay. That is, if suppose f is a function from set A to set B. A to set B. Suppose this one is the set A which contains elements 1, 2, 3 and 4, and here one is the set B which contains A, B, C and D, and this one is the function here which is defined from set A to B. Then by the definition of function states that each element in A has a unique image in B. So here we have to define one function. 1 maps to A, 2 maps to B, 3 maps to B and 4 maps to C. So here we have to check this one is, if f is function from A to B, then each element in A has a unique image in B. But it is not necessary that every element in B has a pre-image. That is, it implies that there are some elements in B which have no pre-image. Here, element D is present which have no pre-image in a set A. Okay, now let us see what is a range of a function f. Range of function f consists of those elements in B, which have at least one pre-image in A. Say A. And if f is a function from A to B, if f is function from set A to set B, then range of f is denoted by f of A. That is, f of A is nothing but contains all f of s such that f is belonging to set A, and f of A is a subset of B. Range is a subset of B. Since here we have to take only those elements from B which have a pre-image in A. That is, for example, C. Suppose this one is the domain A and this one is domain B. It contains three elements A, B, C, and here 1, 2, 3 and 4. So now we have to define one function here. So 1 maps to A, 2 maps to A, 3 maps to C and 4 maps to C. Now domain of function here is A. Codomain is B, and we have to find out the range of a function f. And we know that range of function f consists of only those elements in set B which have a pre-image in set A. So here element A have, that is, range of f consists of only those elements in B which have at least one pre-image in A. Here, set A has two pre-images in A, 1 and 2. And sorry, element A has two pre-images. Similarly, element C has two pre-images which are 3 and 4 in set A. But element B belongs to B, has a no pre-image in set A. So B does not belongs to range of a function F. So range of function F consists of only elements A and C, and which is subset of a set B. Okay. Now, image of a subset. A F be a function function from A to B, and X be any subset of A. Any subset of A, then we say y equal to, which contains all y belongs to F, such that it contains all y, where y belonging to B and y equal to some f of x, or some m belonging to for some x belonging to that capital set x, which is a subset of A, and is called the image of x under the function f under f, and it is nothing but, and is denoted by denoted by f of x is nothing but, that is, here we have to find out the image of set x, which is a subset of A. Let us see some examples. First one, let A equal to A, B, C, D. Sorry, A equal to A, B, C, and B equal to X, Y, Z. And the function here is given, and we say here contains all the ordered things A, X, B, Y, A, Z, and C. Now we have to check whether this here is a function from set A to set B. Let us draw its diagrammatic representation. Suppose this one is the set A, this one is the set B. It contains three elements A, B, C, and it has new three elements X, Y, Z. And this one is the function here. Here, A has an image X, B has image Y, C has an image Z, and A has image Z. So here, element B in set A has a unique image. Similarly, element C has a unique image. But element A has two images in set B, which is contradiction to our definition of a function. But because function the definition of function states that each element in A has a unique image in B, but here element A, small a belonging to A, has two images in set B, which is not possible by definition of function. Hence, the given set F is not a function from A to B. A has element A belonging to A has two images in B, two images in B. F is not a function. Okay, as it is not a function, then it is not necessary to find out the domain, codomain, and range of a function here, since it is not a function. Next example is let set A contains four elements A, B, C, D, and set B contains three elements A, B, C, and let F equal to ordered pair A, B, B, C, 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 and D. And now we have to check whether this set F is a function from A to B. Here also draw one diagram. A, B, C, D. And set B contains three elements A, B, C, and this one is the mapping F. So element A has an image B. Element B has image C. Element C has image C, and element D has image B. So, according to definition of function F, each element in set A has a unique image in set B. There is no element in set A which has two images in set B. So here definition of function holds, since function f of A is nothing but B, f of B is C, f of C is C, and f of D is B. It implies each element in the set A has a unique image in B. As definition of function holds, therefore this set F is a function from A to B. Now find out the domain, codomain, and range. Domain of function F is here. Domain is set A. Codomain is B. Codomain is B. Now range of function F is, by definition of range contains only those elements in set B which have a pre-image in set A, as there are two elements B and C which have a pre-image in set A, but there is an element A belongs to B which have no pre-image in set A. So element A is not belonging to range of a function F. So range equal to F of A is nothing but B and C. Okay. By this way, we have to check whether a corresponding map given this, whether the corresponding set here is not a whether it is a function or not. Next one is operators. If the domain and codomain of function here are the same set, then the function f is called operator. So those functions which have same domain and codomain are called operators. That is, if f is a function from set A to set A, then f is said to be an operator. Okay. Now equality of two functions. Equality of functions. Of two functions f and g defined from A to B, defined from A to B are said to be equal. Are said to be if f of x equal to g of x for all x belonging to set A. Then two functions f and g which are defined on same set A are said to be equal, and we denote it by and we denote it as simply f equal to g. And if suppose that we have to do that the two functions f and g are not equal, that is f is not equal to g if there exists at least one element, there exists at least one element in A, at least one element in A for which f of x is not equal to x. Then we say that two functions f and g are not equal. For example, if f is function defined from 1, 2, 3, 4 to 1, 2, 3, 4 in such a way that f of x will be equal to x, and g also a function from 1, 2, 3, 4 to 1, 2, 3, 4 in such a way that g of x will be equal to x. If we now we have to check whether the functions f and g are equal or not. Here both the functions f and g are equal, since if we take any element belonging to sets 1, 2, 3, 4, f of x is always equal to g of x. Hence these two functions are equal. For example, if we have to find out the image of 2, then f of 2 is equal to 2. Similarly, g of 2 is equal to 2. Then these two functions are equal, since for each element f of x is will be equal to g of x. Now, if suppose 1, 2, 3, 4, now we have to check whether f of x will be to g of x. That is whether functions f and g are equal or not. Here, find out the image of 2 in here. F of 2 will be equal to 2, and g of 2 will be equal to 2 square, and 2 square is 4, and 2 is not equal to 4. So there exists an element 2 belonging to set A such that f of x is not equal to g of x. From this we can conclude that these two functions are not, means f is not. Okay. Thank you for watching the lecture.